Hello everyone, hope you all are doing well. So, today we are going to discuss topic 8, which is the last topic of ecology part, that is advanced tools for ecosystem analysis. Which tools we have to discuss, that is remote sensing and GIS. So this is the topic for today. So first of all, we are going to discuss what is remote sensing. Remote sensing, actually it is composed of two words, that is remote which means that we are not in contact with something, we are not in contact with something, we are not in contact. And there is sensing, which means getting information and data, data like temperature, what is the temperature, pressure, etc. So we are in remote sensing, we are getting the data from an object, from a place, by not being in contact. We are not in contact. So how will you get that? With the help of satellite, with the help of scanning of Earth, with the help of satellite. So that is what remote sensing is. You can define remote sensing that it is used to detect physical characteristics of an area by measuring emitted and reflected radiation by distance. So it is, as we know, not in contact, so that it is at some distance. But how does it measure? By measuring the reflected and emitted radiation. Every object or every surface or every area has its reflectoral characteristics. It emits, it absorbs, it reflects lights, radiations. So that is how remote sensing works. I hope you all get this. Moving on, what are the major general applications of remote sensing? So it is helping weather predictions, forestry, agriculture, to measure surface changes, biodiversity conservation, to measure changes in biodiversity. It is helpful in administrative purposes. So these are the major general applications of remote sensing. But what we need to focus on as it is agricultural option, what are its major applications in relation to agriculture? How can we use remote sensing in agriculture and allied fields? How remote sensing is helpful there? So we're going to discuss some. It helps in crop production forecasting, helps in assessment of crop damage and crop progress. It helps in crop identification, It helps in crop acreage estimation. It helps in crop yield modeling. So as you see, crop identification, how it is helpful in crop identification. Every crop has its own properties, own reflector indexes. So it's so using those properties, remote sensing gets some unique properties of that crop. It is helping crop estimations, identification of pests and diseases. Pest disease identification, soil moisture estimation, soil mapping, monitoring, droughts, stress detection, water resource mapping, in it's helpful in precision farming. So these are some of the major or common uses of remote sensing. Moving on to GIS. GIS, what is GIS? It is Geographical Information System. What is it? It is conceptualized framework that provides ability to capture and analyze, ability to capture and analyze spatial and geographical data. It helps us in capture and analyzing geographical and spatial data. That is what GIS. We have got some components of GIS. The common components are input, output, data, people, etc. So these are the some major components of GIS. It has some kind of input, then it gives its output. It helps in managing data. It helps us people in providing those data. So these are common things. It helps in analyzing geographical and spatial data. So this is what GIS is. Its common applications: geographical mapping and interpretation, mining and mineral exploration, groundwater evaluation or groundwater resource evaluation, environmental analysis, disaster management, transport system. It helps in demographic analysis, that is population estimation. It's in agriculture development. It helps in forestry, tourism. So these are some common applications of GIS. So how does this GIS work? It is very simple. Suppose it takes the satellite images of area. Suppose this is an area with it has got some color and spectral reflectance things in it. Suppose it sees two houses, some trees we can see here. And if we compare with, suppose it is of 2018, we are comparing with 2022, where you see the increase in number of houses, reduce in number of trees in the same place. So by comparing this, we can say that the population of this area has increased, the tree cover has decreased. So this is how GIS works. We compare things, we got into to differentiate things. Sometimes, suppose there are some green trees here. Okay, we are telling this is good forest good, but there can be a green building also, na? How will you differentiate it? So it will take different type of color reflectance. Suppose and in other color reflectance, suppose these are you are getting blue, but this green building will of different color. It will become gray. So that's why how GIS operators differentiate things, and this is how GIS works. And now some major applications of GIS in agriculture. It helps in agriculture mapping, like current and future fluctuations in precipitation, temperature, crop output, area under agriculture, etc. It gives us up information of land covers, information on various land covers, maps and locations on machinery like tractors, where are situations, locations of machineries. Suppose there is a tractor, a truck in the field, you can detect it easily. It helps in soil management. It helps in soil management, soil amendment analysis. As I have told you earlier, how it helps in soil management. When we see different categories of soil, the spectral reflectance of these soils are different. Suppose we can compare the spectral reflectance and that helps in soil management. How much moisture is in this soil, how much nutrients can be present. So this way we can enhance our soil management. We also enhance if erosion identification of soil. And it helps in mapping of water resources. It helps in crop yield estimates. So these are the common applications of GIS and remote sensing. I hope you all understand this. For any query, just comment and press the like button if you like it, and subscribe and save it. So from here our ecology part is completed, and we will move into agronomy part. Ecology is done, we move into agronomy part. That's all for today. Thank you.